The Queen Elizabeth Prize is the world's most prestigious prize for engineering innovation. It celebrates groundbreaking innovation that has had a global impact on humanity. For me, there are two things that make the Queen Elizabeth Prize unique. First of all, although it's about celebrating the very pinnacle of engineering excellence, at its heart is a mission to inspire young people, to inspire a new generation into engineering and these amazing future-shaping careers. And secondly, engineering is a team sport, and because we're able to recognise up to 10 winners, we can better reflect the true nature of how engineering innovation really happens. Tonight is a really special night. We're celebrating 10 years of the QEPrize, and we're delighted that Her Royal Highness the Princess Royal will be here for the announcement, along with Lord Brown, who of course is the chair of the QEPrize Foundation, and a whole raft of exciting people, not least the winners, but also a lot of the younger people who are using their innovation, who are showcasing how that innovation is going to change our lives in the future. Winning this prize is really the absolute top of the tree for an engineer. It means that you've been recognised by your peer group globally as having been responsible for some of the most significant innovations for humanity, and it doesn't get better than that.
But the medical breakthrough of the decade came in 1978 with the birth of the world's first test tube baby. Louise Joy Brown was the first child ever conceived outside its mother's body.
One small step for man, one giant leap for mankind.
Your Royal Highness, my lords, ladies and gentlemen, please welcome your host, Yewande Akinola.
Your Royal Highness, my lords, ladies and gentlemen, welcome to Prince Philip House, the home of the Royal Academy of Engineering. My name is Yewande Akinola. I'm an engineer, an innovator, and a dreamer, and I really am thrilled, beyond thrilled actually, to be here with you tonight to celebrate the incredible world of engineering and to announce the winner of the 2023 Queen Elizabeth Prize for Engineering. Today is about all the wonder engineering brings to the world. We're here to champion groundbreaking engineering innovation, which is of global benefit to humanity. We'll also be giving you a peek into parts of the process that goes towards the decision-making, as well as meeting some of our judges and some of our wonderful ambassadors who do an incredible amount of work to spread the spirit of engineering and the wonderful opportunities in engineering to empower the next generation. It really gives me great pleasure to introduce our first guest. Our first guest is the CEO of the Royal Academy of Engineering, as well as the Queen Elizabeth Prize for Engineering. Ladies and gentlemen, join me in welcoming Dr. Hyacinth Salim, CBE.
Your Royal Highness, my lords, ladies and gentlemen, let me also offer a very warm welcome to Prince Philip House, the home of the Royal Academy of Engineering and the Queen Elizabeth Prize for Engineering. The Academy's charitable mission is to deliver public benefit through engineering excellence and technology innovation. Founded in 1976 as the Fellowship of Engineering, the Royal Academy of Engineering acquired its Royal Charter in 1992 and enjoyed strong support from His Royal Highness, the Duke of Edinburgh, from its inception. He had always been a keen advocate of the role and importance of engineering in society, following his close connections with engineering in his early career in the Royal Navy. As our senior fellow, his enjoyment and his passion for engineering were evident in his many visits to the Academy, and he was a staunch supporter of UK engineering industry and research. Today, we celebrate 10 years of the Queen Elizabeth Prize for Engineering, which was created to champion bold, groundbreaking engineering innovation that is of global benefit to humanity. Generously supported by some of the world's biggest engineering companies, the QEPrize inspires young minds to consider engineering as a career choice and, as you will see this evening, it encourages engineers to push the boundaries of what is possible. As the longest-lived British sovereign in history, Her late Majesty the Queen saw enormous changes in engineering, science and technology during her lifetime, and always took an active interest in new developments. Indeed, she inaugurated many of the UK's most important engineering projects, from the Channel Tunnel to the Diamond Light Source, and she was the first monarch to send an email. We are honoured to have the continuing support of the royal family for the work of the Academy and the QEPrize, and I'm absolutely delighted to introduce the Academy's Royal Fellow, Her Royal Highness the Princess Royal, to now address us. Thank you very much.
Well, thank you for that introduction, but a very warm welcome to all of you who join us here today. It slightly marks the passage of time, but I feel a sort of element of excitement that builds to this announcement. 10 years already, and you've been kind enough to allow me to be involved since the very first one. And my goodness, how we have been able to reflect on just what engineers have achieved in order to get to that point and to move on. I don't envy those who make the decisions on this particular award, because I do think there is so much of real quality and excitement and innovation out there. It is enough that challenges us on a daily basis to try and keep pace. But what is important about this prize is that it picks out the things that really make a difference to an enormous number of people, which is of real benefit to their lives. Now, this prize is the announcement 2013, 17 and 19 winners, and at the presentation ceremony in Buckingham Palace. And we also managed to welcome guests via video message during the lockdowns, well, in 2021 and 22. Well, that marked, of course, one technological advancement that people didn't really catch up with until lockdown and are really much better at it now. Having said that, I hope you're as pleased as I am that we're all back here together to be able to celebrate together. Those also reflect an incredible, wide-ranging example of engineering disciplines of our previous winners. The internet, the World Wide Web, controlled drug release mechanisms, the digital imaging sensors, LED lighting, and permanent magnets. And all of those have had an impact on not just a few, but billions of lives around the world. And in that sense, engineering really does continue to lead the way in providing the solutions. And we have plenty of pressing global challenges for them to come up with solutions for. I find this, for me, this is always an interesting moment. But it also helps, I hope, to raise the profile of engineers on a much wider basis so that lots of people understand the impact that engineers are making on their lives. Not that we can just celebrate what we know they've done, but to spread the word to many more people about what has been achieved by engineers. I was relieved to discover, I've just met a whole lot of young people today making choices about their A-levels and futures. And a huge majority of them are in sciences and engineering type subjects. That was an enormous encouragement. And I hope events like this help to just show them how exciting and innovative that line of career might turn out to be. And the ambition and scale of the winners' work marks this prize, the Queen Elizabeth Prize, I think is the world's most prestigious engineering award. And it really does highlight the link between engineering and innovation. And I would also, of course, like to congratulate all those shortlisted, because I'm pretty sure that we will be impressed with all of them. But my congratulations to the winners.
Thank you, ma'am. Thank you. Every year, the Create the Trophy competition gives promising young engineers a chance to design that year's trophy. And usually what happens is they design it, and the winning design is then 3D printed and presented by King Charles later in the year. Entrants are invited from all over the world, anywhere pretty much on this planet. And last month, we followed the distinguished panel charged with the difficult challenge, really, of selecting this year's winners.
Good evening, Your Royal Highness, my lords, ladies and gentlemen. I am Ian Blatchford, Director and Chief Executive of the Science Museum Group. I'm very sorry not to be able to join you this evening in person, but I'm excited to find out who has won the 2023 Queen Elizabeth Prize for Engineering. Before Lord Brown makes that announcement, I'm delighted to be able to unveil the winning design for this year's Create the Trophy competition. Each prize cycle, we invite young people from across the world to get involved with the QEPrize, using their ingenuity to design an iconic trophy that not only befits the prestige of the prize, but also one that epitomizes modern engineering. The competition does more than inspire young people's creativity. It introduces them to engineering ways of thinking, to consider how their designs, once transformed into real-world objects, will look and feel. It is a testament to its success that as we celebrate the 10th anniversary of both the QEPrize and the Create the Trophy competition, our very first winner, Jennifer Leggett, back in 2013, is now a chartered engineer herself. Congratulations, Jennifer, a real inspiration to all our entrants. Each year, the standard of entries delights the judging panel. Our final shortlist came from India, Italy, South Africa, Austria, Switzerland, Nigeria, and the UK. The design skills on display made picking the winning design a tough decision, but we did eventually agree on the winner, Anya Brandl from Switzerland. Her exquisite design is inspired by the invention of the transistor and the integrated circuit, and how this has been the spur to endless advancements across modern society. These circuits are so ubiquitous that her audacious design encourages us to pause and celebrate what has been achieved. The judges felt the design was sophisticated, confident, and beautiful. Anya will be joining us later in the year to see her design being presented to the winners by King Charles. Finally, I would like to thank my colleagues on the judging panel, Brahma Agrawal, Rebecca Ramos, and Zoe Laughlin, for their valuable perspectives in deciding the winning design. Thank you, and congratulations again to Anya.
Wow. What a stunning design. Absolutely amazing. Congratulations to Anya. This year, the field was very, very strong. So strong that the judges also wanted to really commend the work of one of the entrants. And we are really fortunate that we've got her in the room, I believe. But they were impressed by Eliza Ferrari. Have we got you in the room? There we go. Oh, there we go. We are nearing the announcement of this year's Queen Elizabeth Prize for Engineering. And to give you an idea of the process that goes into deciding who the winner is, we talked with the judging panel really about how they make the incredibly difficult decision of deciding who is worthy, and also why the QEPrize is the world's most prestigious award for engineering.
I think the uniqueness of the Queen Elizabeth Prize is that it's global.
This is the award for engineering that everyone wants to win.
If you see all the awardees so far, they have created transformations. The world wouldn't be the same if their breakthroughs were not there.
The Queen Elizabeth Prize is unique because it involves a breakthrough and also because it's there to inspire young people.
Being a judge on the Queen Elizabeth Prize for Engineering is very tough because you've got to choose between the good, the very good and the excellent.
There are a number of judging criteria. First and foremost, how has it changed the direction of humanity?
There are so many exceptional nominations this year.
We are certainly looking to identify technology that was transformative, that was disruptive.
We have references and we have the experts around the table and we deeply debate the relative merits.
Every year we see that persons change their opinion from the beginning to the end, which is a good thing in a debate.
When we get to the final judging meeting, all the nominations we're considering could win.
The winner this year is truly impressive. Decades of effort combining science and engineering design.
This year's winner is likely to transform our world more than anything else.
It can be used at various scales, from individual families to cities.
This winning innovation helps the environment. It's on the agenda of the principles that we're looking at for the challenges of the future.
Certainly, the recipients will see their lives transformed in dramatic ways.
I hope and I believe that the greatest contribution that the prize has made over the last 10 years is to highlight the importance of engineering to society, but also the excitement and the diversity of engineering as a discipline.
So the moment is now upon us, the moment we've been waiting for to find out who has won this year's Queen Elizabeth Prize for Engineering. To make this announcement, please join me in welcoming to the stage the chairman of the Queen Elizabeth Prize for Engineering Foundation, Lord Brown of Madinley.
Your Royal Highness, my lords, ladies and gentlemen, I think you can gather from those statements by our judges that the Queen Elizabeth Prize for Engineering champions very bold, groundbreaking innovation in engineering and a bit more. So this year is the 10th anniversary of the QEPrize. The first one was awarded to 5 pioneers, the 5 pioneers of the Internet and the World Wide Web in 2013. And since then, the prize has highlighted the essential role engineering plays in connecting societies, enabling international commerce, and strengthening global communities. In 2015, we recognized the impact of controlled release large molecule drug delivery. We gave the prize to someone who is called the Edison of medicine. More recent winners of the QEPrize include the engineers who led the development of digital imaging sensors, the development of GPS, the creation of light-emitting diodes, and the hidden magic of the world's strongest magnets in most of the electric cars you will buy and will continue to buy. This evening is the first of many celebrations on the birth of the prize. In June, we're going to open a new permanent gallery at the Science Museum. It is called, not surprisingly, Engineers, and is dedicated to world-changing engineering innovations and the extraordinary people behind them. The gallery is going to celebrate the global impact of engineering and feature current and future QEPrize laureates. It will inform, excite, and inspire audiences exactly what the QEPrize exists to achieve. As always, we are very grateful to our founding donors of the Queen Elizabeth Prize for Engineering: BAE Systems, BP, GSK, Jaguar Land Rover, Hitachi, National Grid, Nissan, Shell, Siemens, Sony, Tata, and Toshiba. Thank you for your generous support, which has enabled our work over the past decade. In 2021, I announced that the QEPrize would be awarded not every 2 years, but once a year. As the pace of engineering innovation increases, it's right to enable the prize to do the same, allowing us to celebrate even more of the very best in engineering and to honour more engineers whose work addresses the grand challenges of our era and improves the lives of so many people around the globe. Perhaps the greatest of those challenges is the need to combat human-made climate change. To survive, the world needs sources of energy that are zero net carbon, abundant, accessible, and affordable. The work of our 2023 laureates has enabled just that. Your Royal Highness, my lords, ladies and gentlemen, for the innovation and the invention and development of the passivated emitter and rear cell solar photovoltaic technology, which has underpinned the recent exponential growth in high-performance, low-cost solar electricity. The 2023 Queen Elizabeth Prize for Engineering is awarded to Martin Green, Andrew Blakers, Aihua Wang, and Jianhua Zhao. Please welcome your laureates. I thought we might get them to do some work now. So, Martin, I want to start with you if I can. This is the world's, I think, fastest growing energy source, and it's also the one which has experienced the strongest decline in cost over about 40 years. So, having achieved this, I think you started this, how does it feel, and what are you going to do next?
Yeah, well, it's been really quite dramatic, the reduction that we've seen in the cost of solar. So just over the last 10 years, the costs have reduced by a factor of 10. So it really makes it a really viable technology for addressing what some people have described as the greatest challenge humankind has faced, and that's combating climate change. So I think the timing is perfect for this technology getting to the stage where it can be used now to actually displace our use and reliance upon fossil fuels. So I'm very proud to have been involved in the effort to develop the technology to the stage.
Do you think it's got more room to run?
Yeah, it seems to me it's still in the horse and buggy type days in terms of technology development. It can become a lot more sophisticated than it is now. So I'm expecting by 2050 the technology will be much more efficient than we're able to make it at present, and also much lower cost. So some people are talking about ushering in a new era in the history of human evolution, an era of abundant low-cost energy that we haven't really experienced before.
Let me ask you another question, which is, I think, prompted by one of our very first laureates of the Queen Elizabeth Prize, Tim Berners-Lee. And Tim made the very big point that the World Wide Web really works because it's accessible. You don't have to pay to use it. Now, you made a very important decision, I think, when you discovered how to build an effective solar cell as you've done. You didn't patent the invention. Is that right?
That's correct, yes.
And why did you not patent it? You'd think that riches would be on the horizon.
Well, we honestly thought that it would just take too long to become commercial. So we just, we had other technology that we, in fact, thought was more immediately applicable, and we did patent that.
Right.
And that did get used reasonably quickly, but this technology has taken about 40 years to actually reach the market from when it was first conceived.
Do you think it's a good thing that you didn't patent it in the end?
Yeah, no, it definitely accelerated the uptake. So having technology that was unencumbered really enticed the industry to go in that direction rather than alternative directions they could have gone.
So I think this is almost a family, people who've worked together for so long. But I'm going to ask everyone a question. So, Andrew, let me ask you, your early work was very much focused on efficiency, bringing efficiency up to about 20%. What are the key things that you did to make that happen? And what do you think, where can it go from here?
The key steps were to understand where the limitations and losses were in a solar cell. As light comes into the solar cell, you want electrons to come out. Why aren't there as many electrons coming out as you expect? And then focus on the most important limitations, fix those. And then the second most important limitation becomes the most important. You try and fix that. Then you go around the circle and you come back to the first one eventually. So it's like painting a bridge. When you get to the end of it, you've got to start all over again. But each time you go around this innovation cycle, you've pushed the efficiency up a few points.
Do you think there's, and where do you see the limit to this?
There is no limit, essentially. The sun will shine for 5 billion years, then it becomes a red giant and it'll shine even better. The silicon solar cell uses silicon, which is the number 2 element in the Earth's crust. There are no material limits. There's almost no social or environmental limits on solar. It is already the cheapest energy in history, and it's going to halve in cost again, and perhaps even more. It's an era of unlimited energy, and dare I say, too cheap to meter? Not quite, but it is a revolution in access to energy for everything.
Fantastic. We've got, I think, a videotape to show now.
My name is Adrian Pugsley. I'm a research fellow at Ulster University, and a lot of my work is combining solar photovoltaics with solar thermal technology to bring heat and power into the building simultaneously. Mankind has a huge, insatiable demand for energy, and it's increasing all the time. Certainly in the UK, heating demand is a huge, huge user of our energy use. By combining photovoltaics and solar thermal together, which PERC really is very good at enabling that to happen, we can offset even more of our fossil fuel energy usage by reducing our reliance on burning coal and oil and gas, particularly to heat our buildings.
I spend my day trying to come up with innovative ideas of saving energy and also producing energy in a more sustainable manner. So in sub-Saharan Africa, we have problems of unreliable grid. So we wanted to produce a system that is able to provide reliable energy as well as hot water. So the rural communities that we have, the electricity is expensive for them. So for households, it's always a case of, is this affordable? PERC cells are a key innovation for places like sub-Saharan Africa because of the abundance of the sun. So it is a game changer in the sense that it provides reliable energy. It makes a huge difference to your everyday life.
I'm a hydrogen project development manager. The beauty of hydrogen is that when you use it, it doesn't emit any carbon dioxide. PERC solar cells are able to harness the energy from the sun and convert that to electricity. But the sun doesn't shine at nighttime, so we need to be able to store that. And one way of doing that is by converting that electricity to hydrogen and then using that hydrogen in a fuel cell to power a car, or we could generate heat for somebody's home. For the time being, hydrogen is a very nascent industry, and having PERC solar cells is going to help the hydrogen economy get off the ground.
I work for National Grid, and we own and operate the electricity network in the UK. Solar generation is really on the rise, and we are looking to connect and facilitating the connection of solar farms into the National Grid. PERC solar cell technology has already increased efficiency of solar cells hugely. Every % improvement really helps the world to generate more electricity. It's really important to have a mix of energy sources on the national grid, such as solar and wind, to balance each other. Solar is going to be a really large part of the solution to enable us to move to net zero globally.
To Dr. Wang, I think, next. Your work really took the previous efficiency improvements and made a very big breakthrough using PERC technology to get to 25% efficiency. What were the highs and lows in your work to get there?
Well, as an engineer, you always get something, say when you success, you feel very much excited, but you cannot always success. So sometimes it's maybe quite a few years you got nothing. But suddenly, when you design the new experiment, you got a new idea, and then you put into practice, then you got a result. That one is really satisfying. Yeah.
Let me ask you, where do you see the biggest opportunities for this technology in the next few years? Obviously, I asked a lot of questions about the future.
Yeah, industry is getting scaled more and more, so the production will getting, say, supply the world with more powerful the solar cell. So we get more power from this kind of renewable energy. We can use less pollution energy source. I think that would be a very good thing to humanity.
And I think the applicability of this in areas where grids are not possible, where there's energy poverty, is something which can still expand enormously.
Yes, yes, definitely.
Very good. To Dr. Zhao, what do you see as the next big advances in all of solar technology? So what changes do you think we'll see, and what will consumers notice over the next few years?
I think the solar industry with the PERC technology and the other improvement in the passivation and those concept of improved cells, the cell efficiency and cell performance will keep improving, and also with the production tools, the materials, and the entire solar society's collaboration, and the production cost will be further reduced. Not only the cells, but also the raw material, the final product panels, solar panels, and the ways to install this will also improve. And then this will further open the door for a cheaper and bigger application of solar panels, solar technology, and it will further reduce the other conventional fuel consumption and give us a cleaner world.
And if we can store the energy as it's being made, then we can use them for longer and in more different places.
Yes.
I think that's something which I think would happen in the next few years on a very big scale.
The storage for the solar cell generated power electricity is already on the way. For example, it had to be, because the solar cell generates power only under the sunlight. Then at night it doesn't produce any electricity. So electricity has to be stored. And this technology to store the solar cells has been improving. So a lot of companies now making the cheap and high efficient storage devices. And the other thing is, let's say one example is I can think is electrical car. So when you drive to work, and you can put your car with the solar panel system, then you store the electricity in the car battery, and then you can go back home on the way to use this save the electricity. So there are other ways as well to, the smaller mobile system normally has a higher cost, but if this technology is ready, people can make it bigger and safer, and for the home and other facility to store the electricity. So that will make the photovoltaic application more usable and more complete.
Part of a great system.
Yeah.
Can I ask just all of you one question? What piece of advice would you give to a young person who wants to go into engineering nowadays? What's the piece of advice?
Well,
one piece.
I think, in the case of solar, we're in the midst of a massive energy transformation, and there's enormous opportunities and challenges within the engineering field for a young person entering that area. So I think there's enormous excitement about a career within engineering, particularly with these new energy sources.
I think go into something which offers interest so that when you go to work, it's not really work, it's almost like a hobby. But very advantageous if the engineering problem you're working on, or science problem, has mostly upside and very few downsides. Solar cells are pretty useless as a weapon of war, so it's almost all upside. It's a great technology to be involved in.
I would like to see more young girls with a bright brain to get into engineering career. So it will get, I think, get more talent to this area. So it would be very much benefit to everyone and everything.
Good.
Yeah, I would say to choose your career as a young student or scientist, you don't have to everybody squeeze into one narrow field, for example, physics or some other thing. Engineer is a good choice, and engineer is a big area that can take a lot of people to work in engineering. Like when I joined the group, I initially had my training in integrated circuits, and then Martin gave me a choice to actually choose the solar cells. Martin at the time actually have 2 areas for his research. So luckily I chose the solar cells, and I never thought the solar cell can be that big. So it was, I think that was choice, good choice, and everybody can choose engineer as his own choice.
So I think the summary answer is make a good choice. Huh? That's what it is. Thank you all very much. Thank you for being here. Thank you for being part of this. And most importantly, well done for being the 2023 laureates for the Queen Elizabeth Prize for Engineering. It's our great honour to give you that honour, and thank you for being here.
Just amazing. The engineer in me was totally geeking out. That was wonderful, profound. And I guess to end and wrap up the evening, I really have been thinking about the power of possibility. How much engineering is powered by the idea of what might be. I also reflect on the Queen Elizabeth Prize for Engineering, and I remember in 2013, I flew back from Shanghai, where I was living and working at the time, designing super high-rise buildings. And I remember being completely blown away by the idea that an engineering prize was somehow connected with £1 million. Very unusual, ambitious in every sense of it. And so when I arrived and joined a few young engineers, young at the time, like myself, we really saw before us the realization of a big, massive, huge idea, huge ambition. And I also remember the team asking us, and the young engineers, and Angie Hunter, if we would be part of a photo shoot to help with the publicity around the prize. And I thought, yes, why not? That would be amazing. It would be in a studio somewhere. But it wasn't in a studio somewhere. It was on the roof of the Shard. Bearing in mind that the Shard had only been open a few months, and the building was, still trying to find its rhythm. But we were so excited, and I guess the word is inspired, by this incredible prize that was going to raise the profile of engineering. We were inspired by the audacity, the ambition, the amassing of intentional efforts. And in so many ways, I've really picked that up from tonight's winner. And, the PERC technology is wonderful. It really is truly a wonderful example of the universal language of engineering. In my role as an engineer and an innovator, I have the wonderful privilege of immersing myself in a world where, you create things, you hope that they do well, but at the heart of it is humanity. Possibilities around water, transport, energy, manufacturing, but people right at the heart of it. The next generation are at the helm of the evolution of the engineering profession. And I get to see that on a daily basis. It's hugely encouraging. I've got a little story to share, and in a way, it is something that's going to stay with me for a very long time. At the peak of the pandemic, I started to get messages from young students, and they were messaging to say, we're missing out on work experience because companies have had to shut their doors, and we really need this work experience to progress and, go back to university with something. And so I called a few colleagues, former colleagues from all over the world. I probably sent messages to about 30 people. I got positive responses from all of them. And I suddenly went, okay, I've got 30 people willing to spend time online with a handful of students. So I reached out, I put a few messages out on LinkedIn. I got 500 applications back within a week from students all over the world. We ended up with about 100 in the Zoom space and 400 on YouTube, but they were from 25 different countries. They were at universities in different parts of the world, studying different types of engineering, mechanical, water, environmental engineering. But they all wanted to come together to do something impactful for their cities. What was profound about the experience was throughout the week, they were connected, and some of them, some were based here in the UK, some of them in parts of the world on different time zones that they really should have been sleeping and really should have been in bed. But they were committed. They recognized that engineering was going to be their path to bringing about positive change to their immediate communities. And so at the end of the week, when we all got together to see what projects they had been working on, so they'd been working together in groups of 10, I could not believe my eyes. They presented back like they had been in the same room. And there were people who were in different socioeconomic, groups. Some people I could see on the Zoom calls could only really just have that one bulb, to see, the screen. And some of them I had to support with internet connection because they didn't have the internet connection. They couldn't pay for the internet connection. By the end of the week, they came up with solutions that were applicable to any parts of the world. Solutions around building materials for the designs that they had come up with. They were conscious that, yes, you were designing for one region, but actually the solution that you were delivering to that one region was applicable to other regions. They had come up with energy solutions. I guess in a way, it was a little bit of an experiment that I didn't know I was embarking on, but it was the most profound example of the universal language of engineering. And I guess the power of possibility. 25 different countries, different languages as their first language, but really coming together. And now when I work with them, I'm still working with them because I'm just intrigued to see where they're going to go. Some of them are developing solar solutions for the communities. Some of them are designing boring and tunneling solutions that are going to transform the future of transport. Some of them are really doing some purposeful, incredible work around, ensuring that people can live in comfortable spaces. It's truly amazing, and it really makes me proud to be an engineer. And I guess in a way, it connects back to the power and the audacity of the Queen Elizabeth Prize for Engineering, its purpose, its future as well, because I know the last 10 years have been amazing, but we can only expect it to do even more far-reaching good work. Thank you. Your Royal Highness, my lords, ladies and gentlemen, thank you so much for joining us tonight for the Queen Elizabeth Prize for Engineering 2023. And congratulations again to our winners. Hearty congratulations. From me tonight, Yewande Akinola, it's goodbye from the Prince Philip House in the heart of London. Good night and God bless.
It was absolutely fantastic. It was wonderful to be back in person again after 2 years of lockdown events. Absolutely inspirational to listen to Yewande talk about her personal experience of what engineering means to her and the power of engineering to really join communities together. A fantastic group of winners, delighted that they were able to be here as well. And particularly to listen about the passion with which they spoke about their work and the effect that their work has on their communities and indeed the world around them.
I think it's been very exciting, and I'm absolutely thrilled that Martin Green and colleagues have won for the PERC cell, because photovoltaics are such a wonderful technology, and it's been beautifully explained tonight.
Solar power technology through Linde's Prize was very well deserved. It's really a transformative engineering solution that can help us to create a better planet and a safe planet for the next generation.
One of the winners talked about how he worked on the winning technology for over 40 years and how, you know, that just listening to that journey was quite inspiring to me to understand that even though I might face challenges in whatever I'm working on, there's light at the end of the tunnel.
Oh, this year we're very excited, and the winner is Anya from Switzerland, and she had a beautifully developed design. So we also had a special commendation this year for Elisa from Italy, and Elisa was so creative in how she thought about the entire thing. The composition was really exciting.
There's a DJ, there's music, there's artwork. For a quiet retiring engineer like myself, this is quite a big deal. It's a big event. So it's just wonderful to be in a really exciting room where lots are happening, and there's a real buzz about the future of where we're going and everything that we're doing.
I believe that Queen Elizabeth Prize in Engineering has played a pivotal role in engaging with the public and making people understand not just what engineering and engineering contributions are, but also respecting and acknowledging the heroes behind the everyday life that we all enjoy.
So QEP is doing an amazing job as an ambassador to champion engineering, to bring innovation to the forefront, to inspire the younger generation to take engineering. It shows engineering is cool, and it is prize-worthy, and it is worthy of recognition.
I think it's really important to see somebody that looks like you in the future, to see yourself in that role. And I think by the Ambassador Network doing that, but also by showcasing the people that created these incredible innovations, I think it really shows the next generation of the potential that they can have and the impact that they can make.
One of the things that we were particularly taken with when we set up the prize was the voice of the engineering community saying that there was nothing for them to celebrate their achievements. And I think the prize does just that. It shines a light on what the engineering community can achieve when it works together, and it shines a light on just how ubiquitous engineering is and how impossible it would be to live our lives in the way we do today without engineering.